Hello, in this video we want to talk about ergodicity. We have a concept of ergodicity which is related to this course in dynamical system, but we won't talk about it. So the ergodicity here is the ergodicity of a stochastic process. Basically, in many applications, you have access to a temporal sample of a random process. So if you have a random process x of t, so it's a function of time and outcome. This is outcome of your experiment. Outcome of experiment or random experiment. So this c is random and this is time. But we could not have all these time functions. We may have access to these signal for one specific c. So if I have access to one specific random sample, let's say for x1 c, if I could calculate the statistics of this random process using only one single temporal sample or two single temporal samples or some limited number of temporal samples, then we call it ergodic. So basically we say a stochastic process is ergodic if any statistic of that. This statistic could be, let's say, mean of x of t, or it could be another statistic, could be mean of x of t to the power of 2, or it could be mean of x of t plus 1, and let's say x of t minus 1. So this is, you take some samples from these. Let's say here I took 3 samples and then I calculate the expected value of something. A statistic means take a function of some samples of this random process and take expected value. So if you could calculate this statistic using one temporal average of one sample. So if I have a temporal average x of t of 1c for one sample, or and if instead of, because this averaging is, let's say, is integral of, let's say, x of t and then the distribution fx of t of x d x. Okay, so here we have, this is from minus infinity to plus infinity. So this statistic, so is the averaging over distribution. But if you have access to a temporal sample, we could do averaging over time. So let's say if I average it over, let's say, t from minus cap t to plus cap t of dt, if I want to average it, I have to divide this by 1 over 2t. So this is temporal average. So if this temporal average for sufficiently large t gives you the statistical average, then I call it ergodic. So this is because here I have expected value here, expected value of x, then I will call it mean ergodic. But if you have ergodicity for these, you call it ergodic in power and so on. So this means that an average statistical property, that in average and statistical property in practice can be actually obtained by averaging of a temporal values of one signal. And this is important in practice because in many practical applications, you don't have access to all random samples of your stochastic process, but you have some data which you could collect it over time. And then you average it, and then you think that this average is the statistical average of your random process.